Okay, in this section we're going to take a look at reciprocal functions. And let's start with just a bit of a review of what happens when we take a reciprocal. So if we start with the number 2, a reciprocal is 1 over 2. If we have the number 3, a reciprocal becomes 1 over 3, and this pattern continues. 4 becomes 1 over 4, 10 becomes 1 over 10, and 100 would become 1 over 100. And you should notice that as the original number gets larger, 2, 3, 4, 10, 100, the reciprocal gets closer and closer to 0. And this is also true for negative numbers. So if you had negative 2, you'd get negative 1/2, and negative 3 would give you negative 1/3, and negative 4 would give you negative 1/4, and on and on and on until you got to say negative 100, which would give you negative 1 over 100. And all of these reciprocals also get closer and closer to 0. There's a couple other neat numbers with reciprocals. If you took the number 1 and you took the reciprocal of that, you would end up with the original number again. And negative 1's reciprocal would also be the same as the number that you started with. So we've got a couple patterns here. The first pattern is as the numbers get larger and larger, the reciprocals get closer and closer and closer to 0. And a second pattern is if you have the numbers 1 or negative 1, these don't change. Now let's take a look at one other area. What happens as numbers get closer and closer to 0? So if I take a number like 1/2, well, the reciprocal of 1/2 is 2 over 1, which is 2. And then if I take 1/3, the reciprocal is 3 over 1, which is 3. And if I continue this pattern and I do 1 over 100, which is very close to 0, the reciprocal is 100 over 1, which is 100. In fact, if I get really close to 0, with a bunch of zeros here, this is a fraction really close to 0, the reciprocal to that will be a really big number. So, as the numbers get closer to 0, the reciprocals get larger. And there's our third pattern. Now, there are a couple other key bits that we'll put in a second, but let's go back and take a look at how this works with reciprocal functions. So we're starting off with a function, and it's now going to become 1 over that function. For instance, if you start off with y equals 2x minus 1, which is a line, you would get y equals 1 over 2x minus 1, which is a rational function, a type of rational function called a reciprocal function. And from that last section, you'll know that there are some domain issues, that there'll be some asymptotes now, horizontal possibly, vertical possibly, and we can use some of the things we learned in the last section to help us determine where those are. But I want to show you a way of graphing a reciprocal function quite quickly given the original function. So in this case, this is a linear function, and it's fairly easy to graph this. It's just y equals mx plus b. So here's some graph paper, and the points for this, it's got a y-intercept of -1 and a slope of 2. And so it looks something like this, is your original graph. Now, what does the reciprocal look like? And maybe I'll do it in green so it's a little easier to see. But we have 3 rules above, and those rules are really to do with the y values. So the y value of this point right here is 1. It's 1 unit away from this x-axis. And the y value of this point here is -1. It's down 1 unit from that same x-axis. And we have rule number 2 above that says units that are 1 unit away stay stay 1 unit away. The reciprocal of 1 is 1. So this y value of 1 stays with the reciprocal of a y value of 1. And same with minus 1, it stays with minus 1. But as these points get bigger and bigger and bigger in the y direction, so as the y's get further away, the reciprocal graph in that y direction gets closer and closer to 0. And you get an asymptote right along here at y equals to 0. And we know that there has to be an asymptote along here at y equals to 0 because of the rule where the variable on the top and the variable on the bottom get compared, and if the bottom's bigger than the top, then there'll be an asymptote at y equals 0. So that also holds true here. Now these y values in here, and it's a little hard to see, but if you zoom in on this part, the y values, so if this is positive 1 and this is negative 1, and I'm just zooming in right in this area here, there's some parts before it gets to 1, before this gets to 1, when it's going up this way, there's some pieces in here where the y value is only 1/2 or 1/4. And we saw using the rule number 3, as the numbers get closer to 0, as you get closer and closer and closer to 0, your reciprocal actually gets bigger and bigger and bigger. And we know that there is a problem when you actually have your 0. So this is off by a little bit, sorry, on my sketch, but there's actually an asymptote right at 1/2. And the reason that I know it's right at 1/2 is because 2x minus 1 shouldn't be equal to 0, because if it is equal to 0, which is when x is equal to 1/2, you get a vertical asymptote. And so the numbers get closer and closer and go up. On the other side, this unit 1 stays. These go away from the y, so the y's are getting bigger. So the reciprocal of getting bigger is getting closer and closer to 0. You get an asymptote on this side, and where this y value is getting smaller and smaller and smaller, this is getting further and further and further away. And so you get a shape that for this that matches this graph here, and you don't actually even need to use a table of values, really. You just graph your original equation, there it is, and then you use some key ideas that I've listed above to indicate where you graph your reciprocal function. Let's take a look at another example, and hopefully it will make even more sense. So we're going to graph the reciprocal function given a regular function that's already shown. And I'm going to make this one a little bit more complicated because I'm not actually having to come up with this original equation. It's just given to you. So here is my original function, and it's just some curvy function across the Cartesian plane. And now I'm going to graph the reciprocal given this particular graph. And again, this is the x direction, this is y, and we'll make this plus 10 and minus 10 in each direction, just so there's a bit of a scale here for you. And here are the steps to doing this and how they relate to the steps that we looked at for what reciprocal values are. So the first step is identify any points that are 1 unit away from the x-axis. And those points stay where they are. So 1 unit up is right here, 1 unit down is right here, there's another unit down here, and another unit down right there. Those points are called invariant points. Invariant points stay exactly where they are. Step number 2, and I didn't include this before explicitly, so let me make sure that we really understand this. When we're doing reciprocals of the y direction, 1 and negative 1 stay, zeros become asymptotes. And the reason for that is if the y value is 0, then the reciprocal to 0 is 1 over 0, and 1 over 0 is undefined, and therefore gives you an asymptote. And these will be vertical asymptotes, and I'll put them in with a red dashed line. So here's a 0, and we're just looking for basically x-intercepts. Those are what I mean by zeros. And there it is. It looks like it's x equals 4. And there looks like there's another one right there, and that looks like x is negative 4. They won't always be symmetric, but they will always be wherever there were zeros, wherever your function crossed the x-axis. That will give you your new asymptotes. So I don't even know what this equation looks like in terms of algebra statement. I'm doing everything I can just from this original graph. Of course, if you can graph it like we did in the last one, you can do all of these steps from the graph that you produce as well. So zeros become asymptotes. Step 3. If you have values that are getting bigger, their reciprocals will get smaller, which is another way of saying big numbers will get closer and closer to 0. So by big numbers, I mean y values. So as these y values are increasing, the reciprocals are getting closer and closer to 0. And so the reciprocal graph is getting closer and closer to 0. And that gives me a hint that I'm going to have an asymptote. In this direction, here, as these values are getting bigger, the reciprocals are getting smaller. So specifically, if this point right here is -5, it will now be -1/5. So it won't quite get to 0, but it'll look something like this. Fill that point back in. And as these values are getting bigger in this y direction, the reciprocal gets smaller and smaller and smaller, and so it looks like this. So our blue graph is slowly coming together. My invariant points at 1 unit away stayed. My zeros became asymptotes. Big numbers get closer and closer and closer to 0. And 0, or small numbers, get really big. So as these y values become closer and closer and closer to 0, the reciprocals get bigger and bigger and bigger and bigger. As these y values in here get closer and closer and closer to 0, the reciprocals get really big. Just fill that back in. As these ones get small, these ones get big, and as these ones get closer to 0, these ones get really big. And so my blue graph is the reciprocal graph to the black graph that was already originally drawn for me. 1 unit away stays, zeros become asymptotes, and another way of saying big to 0 and 0 to big is the near, as you get closer to the x-axis, it goes far, near goes far, and further away goes closer and closer. So near goes far, and far goes near. Let me show you one last example. Okay, here's a crazy graph. Really doesn't matter what the graph is. We go through all those same steps. So the first one is, and I'll do this in green, find those invariant points. 1 unit away, 1 unit away, 1 unit away, and also down 1 unit. Those points don't move. Now, zeros become asymptotes. So here there will be an asymptote at what looks like x equals 2. And there'll be another asymptote here at what looks like x is 7. And, oh, I missed an invariant point on this side. So 1 unit up, 1 unit down. Zeros become asymptotes. Another thing is that asymptotes become zeros. So I have an asymptote here. It's now going to become a 0. And then near goes far and far goes near. So as this gets closer, the reciprocal is going to go further and further away. So it's going to go skyrocketing up. As this goes up, the reciprocal is going to get closer and closer. It actually gets to 0 because this becomes infinitely big, and the reciprocal of infinitely big is infinitely close to 0. Then on the other side, this is really big. These are big, 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 huge numbers, but they're negative, so the reciprocal is going to be fractions in the negative. As this gets closer to 0, this one's going to get further away and be an asymptote down. On this side, as these numbers are very small in the y direction, the reciprocals will be very big. As this number gets about 2 units away, the reciprocal will be 1/2. So it will dip through like this. And as these numbers get smaller, these get bigger. On this side here, as these numbers get bigger out here, then these numbers get smaller. And it looks like I have a little asymptote right there. And as these numbers are very small, this gets bigger. And there is the reciprocal graph for the original graph that was in black. I didn't need any equations. I just need to follow the steps that are these.